for both the ACTs and the MCAs, the first thing you have to do before you come into the room is you have to clear your memory on your calculator. And the last thing you have to do before you leave the room is clear the memory on your calculator. So if you do have your own graphing calculator, let me remind you how you do that. And if you've got one, take it out right now. If you're going to borrow one from a math teacher or somebody during that day, get one from my desk right now. And let's get that taken care of, because everybody has to know how to reset the memory. And everybody has to know how to set your calculator to degree mode. Well, you'll just have to watch me. Doggone it. We went from having more than enough calculators in here. There must be some people that lost theirs or something, or just didn't bring them to class. So here's what you have to do to be able to clear the memory. You have to hit second and plus, because in the blue above the plus there's a little MEM, and that's memory. And then we're going to hit number 7, reset. And we do have to do all RAM, so we're going to hit number 1, and then number 2, reset. And you'll get this message that says RAM cleared or a reset has been done or something. And then your instructor is going to have to come around and they're going to have to see that it says that before you can even start the tests. So again, one more time, second plus number 7, then number 1 and number 2. And the RAM will be cleared. Now, when the RAM is cleared, the calculator automatically goes back to factory settings, which means when you bought this at the store, the settings that were on there are in there. The problem with that is the ACTs and the MCAs both expect that you'll be able to use degrees on your calculator. So if we go to mode, which is the button just to the right of the blue second button, does everybody see how in black it says radians instead of degrees? You're going to have to change that to degrees once you reset your memory. So you use your arrow buttons to get down there to degrees and then hit enter, and then you should be fine for the test. Now, we can't tell you any of that stuff on the day of the test. You have to know how to do that. So you have to be able to clear your memory, and you have to be able to find degrees under mode and get that in your calculator. Because again, on the ACTs and on the MCAs, they'll work with the problems in degrees, usually not in radians mode, so you're safer to have that there. Now what we're going to do today, probably just want a calculator because there's some bigger numbers, because what we're reviewing today are just some basics of trig. Actually, today and tomorrow we'll do a little basics of trig and geometry tomorrow. So, got that little packet that I gave you, which I don't think has a spot for your name, so make sure you write your name on there somewhere so that you have that. And we're going to start with what is definitely a basic on both tests, which is the Pythagorean theorem. Do you remember the Pythagorean theorem? What is it? A squared plus b squared equals c squared. With the one glitch, and that is that c you have to put in the hypotenuse for. The two sides can go in for either a or b. That doesn't matter, but the hypotenuse must go in for c. So this is what we use when they give us two sides out of the 3 of a triangle to find what's missing. So I look at number 1 and I realize, well, they want the hypotenuse. So that means 9 and 40 are going to go for A and B. And it'll look like that. And then we can either do the squareds in our head, or we could grab a calculator and figure out 40 times 40 is 1600. And 9 times 9 is 81. So 1681 equals x squared. And then how do you undo squaring something? And we would grab the calculator again, and this time I'm just going to do this by hand because we've used square root enough that everybody can find that on their graphing calculator. So that'll be second, and then the x squared button. That's the square root. And then we put in 1681. and we get 41. So that's the most basic use of the Pythagorean theorem, where you are finding the hypotenuse. Now, for number 2, are we finding the hypotenuse? So we have to remember that we're looking for either A or B. It doesn't matter which one. I'll put 48 squared plus x squared equals 50 squared. That hypotenuse has to go over there for c squared. Now, most people don't memorize 48 squared. 2,304 plus x squared equals 50 times 50 is 2,500. What would we do next? Subtract 2304 from both sides. And hope for a nice number, right? $196. Then what do? Square root of 196, do you know that one? 14. There we go. So, basic Pythagorean theorem. All right. Number 3, we looking for a side or for the hypotenuse? Well, then let's get it rolling. $30 squared, 900. 16 squared, I know when I asked you earlier this year, some of you had that one memorized, but some didn't, so 256. And then we need 900 added to that. How do you undo squaring again? Does this one come out nice? What'd you get? 34. Again, probably not one that we had memorized. Yes, 34 squared is 1,156. That was definitely above our 15 squared. Number 4, are we looking for a side or for a hypotenuse? All right, so we'll set it up. Find some larger perfect squares here. 33 squared, 1,089. 65 squared, 4,225. Then what do? Subtract. We'll make the number a little bit smaller. So our 4,225 minus 1,089, 3,136. And I'm guessing some of you already took the square root on that one. What'd you get? 56. All right, so we're not going to let those scare us on either of those tests, right? Going to be able to do the Pythagorean theorem? Okay, so now, here's one sometimes gets forgotten. And this is going to be the special right triangles. So the special right triangles are the 30, 60, 90, and the 45, 45, 90. And there's a little song that goes with those, which usually helps people remember what it is. And that's 30, 60, and 90. It's very easy to see. The short side is 1, the hypotenuse 2. The other side is the square root of 3. And it's 45, 45, 90. These are easy to name, for it's 1, 1, square root of 2 in the triangle game. If you don't know the song, you have to try to remember how do these work, the 30, 60, 90, and the 45, 45, 90. Now, that's the way that they're set up. However, not every 30, 60, 90 triangle has side lengths of 1, square root of 3, and 2. They don't all have that. Not every 45, 45, 90 triangle has side lengths of 1, 1, square root of 2. So what we have to do is know how they're related to each other. And with the 30, 60, 90 and the 45, 45, 90 with a few simple pieces of knowledge, you can get all the side lengths. So with the 30, 60, 90 triangle, that always starts with the shortest side. And the shortest side is going to be the side that's opposite the 30 degrees. The smaller the angle, the smaller the side opposite. So if they give us that, all we have to do to get the long side is take it times the square root of 3. And if they give us the short side, all we have to do to get the hypotenuse is take it times 2. So you can see having the short side is a pretty big deal. If we have that, then this is really straightforward. So what they're going to do is they'll give us the short side to start with, and then they'll say, oh, wait a second, we're going to give you one of these two instead. So to go from short side to long side, you multiply by the square root of 3. To go from short side to hypotenuse, you multiply by 2. If they make us work backwards, we want to find the short side. So to go from long side to short side, we're going to have to divide by the square root of 3. And to go from hypotenuse to short side, we're going to have to divide by the square root of 2. But do you see how the math here is just either you're multiplying or you're dividing? That's it. So it's pretty basic math if you know the pattern. 45, 45, 90s is isosceles. Those are isosceles triangles. So whatever you have for one side length is the length of the other side. And to go from a side length to the hypotenuse, you multiply the short side by the square root of 2. Again, we want the short side, so eventually they're going to give us the hypotenuse and make us look for the short side, which means instead of multiplying, we're going to divide. So that's how these triangles work. These are triangles that hopefully should take you under a minute to do because they're supposed to be special and we're supposed to notice them. So that brings us here to number 5. And I look at it and I see, hey, there's a 30, 60, 90 triangle. But they didn't give me the short side. Rats. Well, they gave me the long side. And I'm supposed to know that to go from short side to long side, you multiply by the square root of 3. So to work backwards, you divide by the square root of 3. Square root of 3's are going to cancel out. So I have 16 for my short side. What do you do to the short side to get the hypotenuse in a 30, 60, 90? Multiply it by 2. So their little s here is 32. We always want the short side, whether or not it's in the 30, 60, 90 or the 45, 45, 90. We want the short side because then we can just multiply to get what we need. Alrighty, taking a look at number 6. They didn't give us the short side. They gave us the hypotenuse. So I start thinking, well, if you have the short side, you multiply by the square root of 2 to get the hypotenuse. I'm going to have to do that backwards. So what should I do? Divide by the square root of 2. But I can't leave that. Why not? Got a radical in the denominator. We know that. The process of getting rid of that is called rationalizing the denominator. So we're going to have to multiply by the square root of 2 on the top and the bottom. So we get 44 square roots of 2 over the square root of 4. But what's the square root of 4? Yep. So we can still do a little bit of simplifying here because 4 does go into 44 11 times. Sorry? Oh, thank you. I said square root of 4 is 2, and then I wrote it down. So 22 square roots of 2. Is it square root of 4? Use the 4 instead of a 2. There it is. All right, let's look at number 7. What kind of special triangle is this one? 45, 45, 90. Did they give us a short side? They did. Both of these are short sides in the 45, 45, 90. What do you do to the short side to get the hypotenuse in a 45, 45, 90? That's it. See how if you know these things, these problems are going to go super fast. You'll be able to just get them quickly so you can spend your time on the harder problems. All right, look at number 8. What kind of triangle is that? (45, 45, 90). It has to be, because if this is 45 and this is 90, what's left for that one? A little 45. Did they give us the short side? They did. So do we know what x is? It's also 20. And how do you go from short side to hypotenuse in a 45, 45, 90? Multiply by the square root of 2. Multiply by the square root of 2. Riley and Zach, pay attention, please. Thank you. So 30, 60, 90s, 45, 45, 90s. Number 9. We know what kind of triangle it is, right? Did they give us the short side? What did they give us? Hypotenuse. So how do we work backwards to get the short side? Exactly. Divide by 2. To go from short side to long side, you multiply by 2. Well, to get back, you divide by 2. Now, what do we do to the short side to get the long side? Multiply by the square root of 3. And there it is. Y is 10 square roots of 3. Take a look at number 10. Did they give us the short side? Remember, what you're checking for is that the side that's opposite the smallest angle? And the smallest angle is 30. So they did. So what do we do to that to get the hypotenuse? Multiply by 2. What do we do to our 15 to get the long side? Square root of 3. And we've got it. Did they give us the short side on number 11? They did not. They gave us the long side, didn't they? Now, how are we going to work backwards from long side to get short side? Divide by the square root of 3. Does everybody see the square root of 3 is just going to drop out? Now let's work forwards. How do you get short side to hypotenuse? Multiply by 2. So again, 30, 60, 90s, 45, 45, 90s, not supposed to be really complicated. It should be something that you look at it and you go, oh, this is what I do with these. And you work forwards. Alrighty, SOHCAHTOA. Got to remember SOHCAHTOA, basic trig. So with number 12, this one says we need to find the sine of D, the cosine of D, and the tangent of D. And the first thing you want to do is say, well, where is D? Because SOHCAHTOA tells us sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we want to label all these sides. So if this is D, which side is opposite that? Right, the 4. It's as far away from it as it can get. It's not even touching the 4. So that's our opposite. Which one is adjacent? The 3, because it has to be a side which is adjacent, means right next to the angle. How do we know that 5 is not the adjacent side? Because it has to be the hypotenuse. The longest side is the hypotenuse. So now we need sine, cosine, and tangent. And we remember SOHCAHTOA. Sine is opposite over hypotenuse, 4/5. Cosine, adjacent over hypotenuse, 3/5. Tangent, opposite over adjacent, 4/3. And if you're saying, well, is that all we do? Yes, that's all I wanted. Sine, cosine, and tangent. That's it. So let's take a look at this one. Can everybody find D? All right, let's label. What would you label the 15? Adjacent. What would you label the 8? Opposite. What would you label the 17? Hypotenuse. Going to call on 3 people to give me those. So take a minute here. Write down sine, cosine, and tangent. Anybody need more time on number 13? Liza, what'd you get for sine? I'm sorry, a little louder. 8/17. 8 over 17. For cosine, Owen, you got cosine over there? Okay, remember, when we say SOHCAHTOA, it's because cosine is adjacent over hypotenuse. So what numbers would we use? Look up here. What's adjacent? 15. What's the hypotenuse? There you go. Alrighty. Tangent. Maddie, you got tangent down? 8/15 it is. SOHCAHTOA. Remember, today's basics, don't overthink. I know it's hard to because we've done things that are so much more complicated than this. But just basics of trig today. Alrighty, let's find D again. What label should we put on 5 square roots of 3? Opposite. Which one gets adjacent? And that leaves, of course, hypotenuse. So once again, I want everybody to do sine of D, cosine of D, and tangent of D. And then I'll call on some people. Anybody need more time to get those down? Melissa, what'd you get for sine of D? Good. We've got opposite over hypotenuse. And then because the 5s, we can reduce 5 and 10. We can do square root of 3 over 2. Cosine. Skylar, what'd you get for cosine? 5 over 10, which reduces to 1/2. Tangent. Tanner, what'd you get for tangent? Exactly. And then we can go ahead and cancel out those 5s. So basics today of Pythagorean theorem, 30, 60, 90s, 45, 45, 90s, and then SOHCAHTOA. And tomorrow we'll go a little bit further with the trig, and then we'll also look at some geometry topics. So got a little worksheet for you, which you could definitely finish before you get out of here. If you've, looking at what you guys did today, I could see some of you were ahead of me all the way through this, so it's not going to be tough at all.